In this video, we'll cover part of the environmental impacts section. There will be more environmental impacts material in the course following the video. Ozone and atmosphere basics. Ozone, or O3, is a naturally occurring gas found in the atmosphere. It consists of 3 oxygen atoms. In chemical formulas, the subscript number indicates the number of atoms of that element in the molecule. For example, water, or H2O, has 2 hydrogen atoms and 1 oxygen atom. Around ground level, or in the troposphere, which is up to about 10 kilometers above the surface of the Earth, ozone is considered a harmful pollutant. In the upper atmosphere, or stratosphere, above the troposphere, extending to about 50 kilometers above the surface of the Earth, ozone forms an important shield that protects the Earth from the sun's harmful UV rays. Depletion of the ozone layer exposes life on Earth to intensified UV radiation, which includes effects such as increased risk of skin cancer, increased risk of cataracts, and decreased crop yield. It can also be harmful to marine life. Destruction of ozone by chlorine. When ozone is in the presence of chlorine, written as Cl, it will react with the ozone to create chlorine monoxide, written as ClO, and oxygen, written as O2. Chlorine monoxide will then react with another ozone molecule to create 2 O2 molecules and a chlorine atom. The chlorine atom then reacts with another ozone molecule, and the process repeats itself. Through this cycle, it is estimated that a single chlorine atom has the potential to destroy 100,000 ozone molecules. The diagram on the right depicts this process. Also, nitrogen, N, hydrogen, H, and bromine, Br, will react with ozone in a similar way to chlorine. Introduction to CFC and HCFC refrigerants. Refrigerants such as chlorofluorocarbons and hydrochlorofluorocarbons contain chlorine. When these refrigerants are released into the atmosphere, they break down, releasing the chlorine atom, which, in turn, rapidly destroys ozone. Identification of chlorofluorocarbon, hydrochlorofluorocarbon, and hydrofluorocarbon refrigerants. The idea here is not to memorize the chemical formulas, but to be able to identify which refrigerant falls into which category. This chart shows which refrigerants fall into each category. It also shows which atoms the refrigerants contain. We'll revisit this chart after the video so you'll have a chance to give it a closer look. Use the color coding on each to help you memorize what category the refrigerants belong to. Next, we'll review this table and go deeper into the refrigerants themselves. When this video is finished playing, scroll down and click the blue Continue button to continue with the course.